This is the first in a four-part series on the basics of statistics, describing a given collection of data. Part 1 considers the measures of central tendency. The three measures are defined, along with the method for finding each, and examples are provided. Part 2 considers percentiles, specifically the quartiles. We define the measures, learn how to find them, and look at examples. We also consider other measures to describe a set of data. Part 3 considers creating a box and whisker plot to provide a visual depicting all the measures defined in the earlier parts of the series. Part 4 considers the measures of spread, specifically the standard deviation. This measure is defined, as is the method for finding it. We look at an example in detail. Suppose we consider some population. If we selected a random member of the group, what would they be like? For example, suppose we consider the population comprised of all the males in America. Research has shown that the average American male stands 5 feet, 9 inches tall, and weighs 195.5 pounds. Or suppose we consider the population of all American households. The 2012 census suggests the typical American household has an annual income of $50,500, or $69,821. Wait, what? How can the income of the typical American household be two different possible answers? This is because the typical, average member of a population can be described by three different possible measures of central tendency. The three measures of central tendency are the mean, the median, and the mode. The mean, officially the arithmetic mean, is the average of the numbers. The median is the entry that is in the center position when all the numbers are listed in order from smallest to biggest. The mode is the number that appears the most often. Let's look at each of these measures of central tendency more closely, starting with the mean. The mean is the average of the numbers, and is central to much of statistics. There are two different notations for the mean. The first is the Greek letter mu, which is the average of an entire population. The other notation is x bar, which is the average of some samples of values from the population. The official mathematical definition of the mean is the sum from I equals 1 to I equals n of the x sub i's divided by n. In this definition, the x sub i's are the individual values, and n is the number of values. So to find the average, first we add all the entries together. Once we have that total, we divide by the number of numbers. The median is the middle number, much like a median is in the middle of a highway. The one condition is that the numbers must be listed in order from smallest to biggest. To find the median, first we need to ensure that the numbers are in order. Then cross off the outermost pair of numbers, the smallest and the biggest, until only one number remains. If we have an even number of numbers, then the median will be the average of the middle two numbers. The mode is the number that appears the most often. To find the mode, we just figure out which number shows up most frequently by looking over our list of numbers. However, some groups of numbers may have multiple modes if more than one number appears the same number of times, or not have any mode at all. Now that we have defined the three measures of central tendency and how to find each, let's look at an example. Sam's student is a student at Empire State College. In one of their studies, Sam got scores of 80, 60, 90, 85, 70, 30, 85, 100, and 75 on their assignments. Sam wants to succeed and have a good grade point average. Which measure of central tendency would Sam hope the instructor uses as a grade? In other words, which of the three measures is highest for these scores, the mean, median, or mode? In preparation for finding the median, we start by putting the scores in numerical order. But before we go through the process of determining the median, first let's find the mode. It is the easiest measure to find. The mode is 85, since it is the only score that appears more than once. Next, we will find the median. Since the numbers are in order, we pair up the amounts at the ends. The 30 pairs up with the 100, 60 with 90, 70 with 85, and 75 with the inner 85. This leaves only the 80, so that is our median. To find our final measure of central tendency, the mean, we start by adding all the scores together to get 675. We finish by dividing by 9, since there were 9 scores. Our mean is 75. So Sam should hope their instructor uses the mode as the grade to receive their highest possible grade. Let's look at one more example. In another study, Sam's student got scores of 95, 75, 60, 85, 65, 95, 95, 70, 75, and 80 on their assignments. Again, Sam wants good grades, so which measure is desired for this? Start by putting the scores in order. When we do so, we notice that this set of scores is bimodal. This is the official term for when we actually have two modes for a set. In this case, the scores of 75 and 95. In pairing up the scores to find the median, we are left with two scores in the middle, 75 and 80. To find the median, we have to average those two scores. We add them together to get 155, then divide by 2 to get our median of 77.5. Finally, we find the mean by adding up all our scores and dividing by 10, since we have 10 scores. This gives us a mean score of 79. Now that we know all the measures of central tendency, we determine that Sam wants their score in this study to be defined by the mean, since that has the highest value. Let's summarize this resource. We discuss the idea of central tendency statistics, which provide an idea of a typical member of a group. There are three measures of central tendency: the mean, the median, and the mode. The mean is the average of the numbers. The median is the middle term when listed in numerical order, and the mode is the entry that appears most frequently. However, these measures of central tendency provide an incomplete picture of a data set. Consider the set 50, 60, 70, 70, and 100 versus the set of 5 copies of 70. The mean, median, and mode for both sets are all 70. But the two sets of numbers are very different. We need to find statistics that show whether the numbers are closely packed or if they are all spread out. And we will, in the next resource in the series.